All right, today we're going to pull back the curtain on artificial intelligence. And I want you to forget all the sci-fi stuff, all the crazy jargon for just a minute. Because we're going to show you how this entire AI revolution, all of it, actually starts with a simple bit of math you definitely learned back in high school. Let's dive in.
And no, I'm not kidding. This right here, this simple idea is the key. The exact same logic that we all use to draw a straight line on a graph is, and this is wild, the fundamental building block for the most advanced digital minds on the entire planet. And we're going to show you exactly how that's possible.
So, before we get any further, let's just level set for a second. What do we actually mean when we say AI? I mean, the term is absolutely everywhere, right? But what is it really at its core? We need a clear foundational definition.
At its heart, it's pretty simple. AI is really just the science of building smart machines. It's all about creating systems that can take in information, perceive the world, understand what's going on, learn from it, and then actually use that knowledge to solve problems. Pretty much just like our own minds do.
And you should know, this is not just some academic theory stuck in a university lab. Get a load of this number. In 2024 alone, private equity investment in AI shot past $124 billion. That figure tells you something really important. This tech is a massive economic engine that is actively reshaping our world as we speak. So understanding it, it's not really optional anymore.
So, the big question, how does a machine actually learn? Let's circle back to that simple equation from the beginning. This is where the magic really starts to happen. And trust me, it's a lot more intuitive than you might think.
Just look at this. I mean, it's practically identical. In machine learning, we just swap out the words. The slope of the line, that becomes a weight. The y-intercept, where the line starts, that's called a bias. That's it. These are just the two dials the machine can turn to try and find the perfect line that fits whatever data you give it. Yeah, just think of weights and biases as the tuning knobs on the machine. The weight is like a volume dial. It tells the machine how important a particular piece of information is. And the bias is just a little nudge, kind of like a starting point. The entire process of learning is really just the machine tweaking these two knobs over and over and over, thousands of times, until its predictions get better and better.
Okay, so that's one tiny little learning machine, one simple line. But how in the world do you get from that to a complex digital brain that can write a poem or recognize your face in a crowd? Well, you scale it up. You don't just build one, you build a network.
And this is the basic building block, the artificial neuron. At its core, each one of these is still just doing that simple y = wx + b calculation. It takes in some data, it applies its own unique weights and biases, and then it makes a simple decision. Do I pass a signal on to the next guy or not? Now, one neuron all by itself is pretty simple, but when you get millions or even billions of them all working together, that's when things get incredibly powerful. And these neurons aren't just a big jumble. They're organized into layers. Think of it like a factory assembly line. The raw data, let's say all the pixels in an image, comes in through the input layer. Then it passes through these hidden layers, where different teams of neurons act like little specialists. The first layer might just spot simple edges and lines. The next layer takes those lines and looks for shapes, like eyes and noses, and so on until a later layer can recognize a complex idea like cat. Finally, the output layer gives you the final answer.
Now this right here shows the absolute game-changing shift in thinking. Old school AI, what we call symbolic AI, was so fragile because humans had to sit there and write out every single rule by hand. If you see this, then do that. But if it saw something new, it just broke. Modern neural networks are totally different. We don't give them the rules at all. We just show them tons and tons of data, like millions of pictures of dogs, and they learn the rules for themselves. That was the huge leap that finally let AI handle the messy, ambiguous real world.
And this new ability to learn from data led to a massive breakthrough in 2017, a new kind of architecture called the transformer, which, by the way, is the engine inside things like ChatGPT, finally solved a huge problem that had been holding AI back for decades: understanding context.
Let me frame the problem for you with a simple question. When you read a sentence, your brain just effortlessly figures out what pronouns like it or they are referring to. But for a machine, that is an incredibly hard problem to solve. Look at this sentence. We know instantly that it refers to the animal, not the street. A street can't be tired, that's obvious to us. But how is a computer supposed to figure that out? The word it has no real meaning on its own. It gets all its meaning from the words around it.
The answer was a truly brilliant mechanism called self-attention. And here's the best way to think about it.
Instead of reading a sentence one word at a time, a transformer looks at the entire sentence all at once. And for every single word it asks, to understand me, which of the other words in this sentence are the most important? It basically creates this invisible web of connections between all the words. In our example, it learns the connection between it and animal is super strong, while the connection between it and street is really weak. And just like that, it gets context.
And that single idea, laid out in a now famous paper with the perfect title, "Attention is All You Need," is what unlocked the whole generative AI explosion we're living in right now. It's the reason AI can suddenly understand and create language that feels so, well, human. Okay, so where does all this go from here? We've gone from a simple line to a system that can understand language. The next logical step is for that system to start taking action. We're on the cusp of AI moving from being a passive tool to an active teammate.
So say hello to agentic AI. This is the new frontier. We're not talking about chatbots anymore. These are systems designed to be true virtual coworkers. They can plan, they can carry out complex multi-step tasks, and they can use other digital tools all on their own. So you don't just ask it to find you flight options to Tokyo. You say, plan my business trip to Tokyo. And it goes out, books the flight, reserves a hotel, and puts it all on your calendar without you lifting a finger. Now, this chart tells an absolutely incredible story. The innovation score for general AI is way up there, super high. It's a developed field. But for agentic AI, the score is literally 0. Now, that doesn't mean it isn't happening. It means the field is so brand new that the big breakthroughs haven't even hit the scoreboard yet. We are standing at ground zero of a technology that is about to completely change how we work.
So the future of work looks like it's going to be all about collaboration. You know, the whole conversation is shifting away from AI is going to take my job and toward how will I use AI to do my job better? It's about augmentation, where humans and AI agents work side by side as a single integrated team to solve problems that neither one of us could solve alone.
And that brings us to the final and maybe most important question. We've seen how AI works, all the way from a simple line on a graph to a complex network, and now to a potential virtual coworker. But as AI evolves from a tool we use into a teammate we collaborate with, the biggest question isn't really about the technology anymore. It's about us. Are we ready?